horizontal force of 100 Newton is needed to pull a 50 kilogram across the horizontal floor. What is the coefficient of friction between the floor and the box? First, we will write our given, and this will be the drawing. So we have here our 100 Newton, and then the mass of that box is 50 kilograms, and we are looking actually for the coefficient of friction. And what kind of coefficient of friction? We're looking for coefficient of static friction. So we write here now our required. That is the coefficient of static friction. Let's draw first our free body diagram. Now, so we have to represent it with a box. And we have here the applied force, which is the F up in an X direction. And we have here 100 Newton. And then we also have the frictional force. So we will represent it with a small letter F. And we also have the weight of the box. So what is the weight of the box? Since the mass is 15 kilogram and we have the formula of mg, so we have here 50 kilogram times 9.8 meter per second square, and that will result to 490 Newton. And we also have the other component. Since it is lying on the surface of the floor, we have the normal force that is keep pushing it upward. There's a Newton's third law, which is a reaction force. So if there's a force going down, there's a force going up. Now, what is now our equation? Our equation, in order for us to get the coefficient of static of friction, remember that frictional force, we have the mu static multiplied to the normal force. And to get the mu static, that is simply the force over n. The summation of Fx equals to mass multiplied to ax, or acceleration, the x-axis. But since we are talking that a horizontal force of 100 Newton, it is the force needed to move the box while it is stopped. Therefore, we could say that the acceleration is 0. And then, we could now say that the summation of Fx is equals to 0. Now, what are the components of Fx? The component of Fx is this. We have the F up x and the frictional force. So we have now the F up x minus, why minus? Simply because it is going to the other side. And remember, force is a vector. Minus the force is equals to 0. And how about for the summation of Fy? For the summation of Fy, since that box is not moving up or down, and we have this equation, ma in the y direction, so therefore the acceleration is 0, we can now say that the summation of Fy equals to 0. Again, simply because it is not moving up and down. What are the components of the Fy? We have the normal force, which is going upward, so it's a positive sign, minus the weight equals to 0. So we have now our two basic formula. We have this F up x minus F, and n, the normal force minus the weight, equals to 0. So if we're going to look with our equation, our goal is to simply look for the frictional force and look for the normal force. Let's proceed now with our solution. So we have F up x minus the F equals to 0. That's our first equation coming here. And our F up x is 100 Newton minus the F equals to 0. And therefore the force equals to 100 Newton. Next, how about for the other one? We have here N minus W equals to 0, and our normal force minus the mg, which is the 490 Newton, coming from here because that is the weight, equals to 0. Therefore, N is equals to 490 Newton. Let's go now to our primary equation. We have here the mu static is equals to 100 Newton for the value of F minus 490 Newton for the value of the normal force. Then we have to cancel the unit. Therefore, the coefficient of static of friction, that is around 0.204. Now, take note that we cancel the Newton, so therefore the coefficient of friction has no unit. And this will be our final answer.